be patient with me for a moment. Before I show you any jigs, there are a couple of concepts I want to expose you to. First of all, look at this. It's a circle. And now look, as you look at the circle slightly from its side, it becomes elliptical. Do you see the arch-like ellipse sort of thing there? And as it keeps going, it eventually just disappears and turns to a vertical line. Similarly, the same thing happens to a saw blade. When you approach it head on, you have a vertical cut, but if you approach it from an angle, see what happens? And you can turn that ellipse all the way this way until it's a circle. Here, flip the footage upside down. This is somewhat of an elliptical shape. It's actually called a catenary. And look. You can think of these ideas as we move through the video. Next, I want to show you my feather board. This is the only one I've ever made. I don't use it all that often, but it's great when you do use it. There's just some vinyl electrical tape there, and that acts as a cushion. This is polyethylene T-track, I guess you could call it. I made it myself. There should be a washer on there, but I don't need it for the demonstration. It grabs pretty well. If you have no idea what it does, let me show you. Let's say we're running this through the table saw. We set the fence so that it's a little bit tighter here on the heel of the feather board. Lock the fence down, make it nice and snug, tighten. And now the feather board allows the stock to pass through, but it doesn't let it come back. These little things, as individuals, are not very strong, but they have a collective strength that's impressive. And so let's combine all these ideas. Every time that I've had to make a cove molding, this is how I do it. I end up using this feather board thing as my fence, and then I run my stock through it. It's not ideal because this thing is not long enough, and plus it only attaches to the T-track in one place, so it's kind of sketchy, but it's got me through. But I started playing with new ideas because I got sick of doing this, and well, I'm not there yet. I do have some ideas that I can share with you, and I'll show you how it evolved. It started by, what if we had a series of adjustable holes so that I could place it in a bunch of different angles here. That takes care of one point, but now I want to make it stationary here, and I'm restricted to my T-tracks there or there. Okay, it's a problem because if I go this way, I don't have enough table saw to keep from going over the blade. So let me explain the problem this way. If I want to make a cove in the middle of my piece, what if my stock is really thick? What if I have a 12-inch board that I want to put a cove on? Then this just doesn't work. So once I started to think about this, I started to realize that it's far more complicated than I had thought. Now let me add another complication to this. As we move around our blade, our vertical cut becomes elliptical, and then it eventually becomes a semicircle. Okay, you've got that much, but there's another variable that we can throw into this. So far we've been talking about changing this aspect of the curve, but you can also change the angle of the blade, and that causes the curve to become asymmetrical. What's my point? My point is that it's complicated. If it looks easy, then something's misleading. Here's an example. This is called the tremolo of Archimedes, or a nothing machine, or an ellipsograph. So it draws an ellipse, and it might look at first glance like, wow, what a great tool, you can use that to draw any ellipse, but you can't. You can only draw a certain type of ellipse with this. You can adjust it for size, but no matter what you do, because these points are already determined, the shape of the ellipse is forever constrained to this style. And just as we turn the saw blade and an ellipse changes, you can do something like that to this by changing these points. This is a head scratcher that you should think about. My point being that if you watch a video like the one I've made about this, it would suggest that it's easier than it is, when in reality there's a lot going on here. So, from a pragmatic point of view, I've pulled myself through just about every attempt at making a cove by either clamping up some rig, or, all you have to do is put a board across the way that you need it and clamp it down and you should be good to go. It might be sketchy, and that's what I'm trying to avoid here by bringing all of this to your attention. But there won't be one jig, at least it's not likely that anybody's going to come up with one jig that can do everything. Because in order to do that, we're going to need to be able to position a fence just about anywhere. And also, it has to be with respect to a certain distance to the blade. There's just too many variables to account for. But I'll show you some of the gimmicks that I have here that can get us through most things with just a few simple gizmos. And we will start by making one of these T-track things. We're after 2 of these. If you've never cut high density plastic before, you want a sharp blade. Don't go too fast or it could jam, and don't go too slow or it'll melt. For this one I cut out a little groove for the head of the bolt, but I think we can skip that step this time, and I'll just drill out a hole so it'll nest down in. Now I just have to match all of these dimensions. There is almost zero play left to right, but you can see that the table is a bit proud. This sits down in, and that's so as you tighten the bolt, this T-track picks up tight against its groove and it gets really secure. This is not wood, it's plastic. See the crown that it has? It's better for a table saw if the piece touches here and here than if it were to touch in the middle and rock. But since this is plastic, we can just give it a little bit of a flex until it's correct. You can't really count on the sanding too much. Think of the sanding more like deburring. But you can drag a razor blade across it, much like you would a scraper. And that can remove a small amount of material. Just be careful on your cuts. you don't mind, you're standing a bit close there. Now that we have all the parts, in go these T things. And these plywood blocks are the same as the fence. Take a close look. All three have a table saw cut in them, and that's so that this little C channel fits in there perfectly. The hole for the bolt is positioned such that the bolt is tangent to the face. That gives us quite a bit of mobility. There's a lot of options here, and it's pretty easy to adjust. And I know the question on your mind is, does it hold? Okay, tighten this down. Yes, it holds quite well. Now, because it's only attached up here with the C channel, if you put pressure on the back here, you could pop it loose, force it out. But luckily, when you're making a cut, any pressure that you're applying is applying against the fence, and it's really good at absorbing that. Of course, this won't work for every possible cove that you would want to make, but it gives you a lot of options. This will cover lots of bases. And what's nice about it is that you can gently fine-tune it. Because with a cove, when you're trying to match this to the shape of a specific cove that you want to cut, it requires a lot of tinkering. You'll need minor corrections here and there. This seems, off the top of my head, to be good for any cove angle that would be from 0 to a little over 45 degrees. If you wanted to go tighter than that, like a super steep cove, then this thing might be the better choice. So I never really finished showing you how the top operates. We put this in place first. There's another T-track up here, and we can use this as a fine adjust. So you can set your point down here. I'll start, I don't know if you can see. Let's position this back in the middle. Okay, now I have this one somewhat stationary. Now let's look up here. This gizmo gives us a really nice ability to make fine adjustments. And again, the question you're asking yourself right now is it tight when it's tightened? And the answer is very much so. More so than that other fence, actually, because if you look at these, it kind of makes a triangulation which locks it into position. This piece was sanded from just probably a 32nd of an inch to nothing here, and that gives it a little foot on the end that applies pressure, and it benefits from the leverage that it gets. And so if you think about this when it's all put together, you tighten this down and it causes this to pop up. You tighten this down and it causes that foot to apply tons of pressure. Looking at it overall, pretend we want to make this cove here. How do I don't really have the nomenclature to describe this. A cove that's tight like this, I'll just call it small for now, it's rather small. So this jig would be the appropriate one. A cove that's opened up rather large, the fence one would be a better. As it crosses over that blade, it's going to touch this point and this point. I had to scratch my head for a moment and think about what I wanted to say. Okay, there are three things that we're lining up when we're doing this. There's the inside of the curve, the outside of the curve, and its height. Now the height is pretty simple. You put this against the table saw, or you put it against the blade and raise the blade until that corresponds with that. But these are a little tougher to guess. We'll rotate a tooth down until we find this spot on the insert plate. That's where it's going to start. And so we want to cross through there. Now the same thing happens over here where the tooth meets the insert plate. So we'll move the back end of the jig. This would be wonderful if it were a slot, but I would lose too much strength doing that. It would make adjustment great, but it's not really appropriate for wood. Now you might think, what about a gill sort of design where you have overlapping slots like this, and then each of those could potentially cover the entire width of the board without really affecting the strength too much. Okay, yes, that's possible, but geez, how do you establish that curve? I mean, that's a whole rabbit hole that I don't want to tumble down. Similarly, we could apply that same sort of thinking up here with some type of fish gill thing. But the essence of what we're going for is simplicity. The ultimate goal of presenting a good, solid idea that's repeatable is to have something that's sufficiently simple. It has enough of the bugs worked out, and I'm not doing that here. I'm showing you how not reduced I have it. So I've set my lower pin to what is a good guess, because it's close where it passes through both points, but it hits there. And so, see my pencil mark? It's right where I want it to be. And this is where I want it to end. And so now I can adjust this until it hits where I think it will be. When you're making a cove, you can't take it all at once anyway. You only take a little bit at a time, and so that little bit at a time is going to start in the middle. And we'll take just a little nibble out of this, and then we'll make little adjustments as we go. Each time just taking a little. This might take 4 or 5 passes before I nail it. There are more mathematical ways to go about it, but you might attempt a project like this with a structure like that, but that structure will collapse as you go forward, and you will eventually find yourself muddling through it using your hunches and intuitions anyways. So there you have it. A rather imprecise guide to cove jigs. I wish there were a better way to tell you this, but that's just how it goes with making stuff. All of creation is, you know, if there was just a better way to say this. I have a message in here somewhere. I guess looking at the big picture, find the simplest, most efficient way possible. If you can just put a 2x4 across the table saw and clamp it down and get your job done that way, I suggest you do it that way. Hope you don't consider this a waste of time. Or we can consider time spent in problem solving and improvement a good use of our time. So I added another one of these doohickeys, and that just makes fine adjustment easier on this side of the cut. Quick review of a cove molding. There are 3 things that you need to remember: height, left, and right. We'll use height to determine what the points of the left and right sides of our molding will be. we'll put the right mark on the right side of the insert plate and the left mark on the left side of the insert plate. Then we'll drop the blade down and slowly approach until we get the desired height. Remember, no matter what you do, when you're making a cove molding, you're going to end up with some variety of an elliptical shape. So the object of the game is to match the closest kind of ellipse to your particular cove that you can find. I'm pretty close here. I could probably adjust my cove just a little bit that way by using the fine tune on the, let's call this the back side of the table saw. But another thing that I can do is also flip my stock over and come from the other direction, and that will force this molding to be perfectly symmetrical. And so I've made an adjustment of about 1/32 of an inch here, and given the leverage, it will be even less at the blade. And that's my best guess for my second to final pass. So let's see how close I got. I raised up just a little bit. I will make my final pass when I'm doing the other side, and I'll make both final passes on both halves of the molding, because like I said, I want perfect symmetry. Okay, yes, I'm totally pleased with this thing. It's definitely better when you have both adjustments. It just really makes it nice and simple to give it a fine tune on both ends. Also, I put some plastic on this, just to lower the friction. Always improving. Okay, this has gone on long enough. If you want to find out what that's about, you'll find it. It will be in a different video. See ya, thanks. Not bad at all. And that's with no sanding. By the way, there were 5 Easter eggs.